Okay, hello everyone. So this is the solutions to the March 23 class worksheet. So this top molecule here, Taxol, is a very large complicated molecule. It was isolated from a natural source, the Pacific yew tree. So in order to identify chirality centers, right, we need to find carbons that have 4 different groups attached to it. So for example, if we start over at this end, we have this aromatic, the nitrogen, this carbon with the OH, and let's not forget that there is a hydrogen bonded there, so that's a chirality center, 4 different groups. This next one, OH, this carbonyl, this large part of the molecule, and once again, let's not forget, there is an H there, so that's a chirality center. Moving on down, we have this part of the ring with the alkene, this part of the ring with the CH2, the O, and once again, there is an H there that's up, so that's a chirality center. Likewise here, the oxygen, this ring with the alkene, this ring, and now our hydrogen is back. So that's a chirality center. Here, the 4 groups are already there. This is a methyl, the carbonyl, this part of the ring with the OH, and the bottom part of the ring. So that one's a chirality center. This OH, the CH2, this part of the ring, and once again, there's an H back. That's a chirality center. Here, the oxygen, the CH2, the bottom part of the ring, and once again, an H back. That's a chirality center. Here we have this top ring, the O, this, and this, 4 different groups, that's a chirality center. Here, H back, this ring, this ring, this ring, that's a chirality center. Likewise here, this is going to have an H that's up, the oxygen, this part of the ring, and the part with the O. And last but not least, this one, we have this part of the ring with the 2 methyls, this big ring, the small ring, and the OH. So that one is a chirality center. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I didn't mark that one, sorry, 10 and 11. So we have 11 chirality centers. And the total number of possible stereoisomers is 2 to the n, where the n is the number of chirality centers, so it's 2 to the 11th. So that is 2,048 possible stereoisomers. And again, that one and that one only is the one that was isolated from the Pacific yew tree. So pretty amazing, okay? Bottom one, drawing Fisher projections, okay? So this molecule has 2 chirality centers, and as it's currently drawn, it's actually in the staggered or anti-conformation. So what we first need to do is rotate around this carbon-carbon bond between the 2 chirality centers and get it into the total eclipsed conformation. So that would look something like the following. This left-hand one, we didn't do anything to. We left that alone. So that's the H and the chlorine. This right-hand one, though, if we're holding this, we rotate that around so that this ethyl group comes down. This methyl, as you rotate it, goes back. So the CH3 is now going to be in back. And this H that was in back, as you rotate, comes out in front. Okay, so that is now the total eclipsed conformation. Then you need to take that and tip it 90 degrees so it's facing you. So this H, chlorine, H, and methyl are all facing you. And I'm sorry to say I don't have molecular models, so you're just going to, if you have them, please try it. And I did show you an example of that in the video. But when you tip it to then draw the Fisher projection, it looks something like this. And again, if we tip it this direction, the methyl is here, and that's back. The ethyl on the other end is there, and it's back. We then have the 2 H's on the same side, and the chlorine and the other methyl group on the same side. And again, those 2 are the chirality centers. So once again, we've rotated it to get it eclipsed and then tipped it so it's in front near us. Okay, so to draw the enantiomer, we simply put the mirror image there, right? And then we draw another Fisher projection bars. The methyl's on top, ethyl is on the bottom. Now the chlorine and methyl are on this side, and the 2 H's are over there. So those are mirror images of each other. And again, that's the 2 chirality centers. And those are not the same, because if you take this up and set it there, the chlorine and methyl are on the wrong side. If you spin it this way, the methyl and ethyl don't match up. So those are, in fact, the enantiomers. Okay, so with that, let's go to this last one, identifying R and S. Okay, so this top chirality center, again, remember oxygen is number 8, that's going to be A. Hydrogen is atomic number 1, that's D. We have this carbon with 3 H's and this carbon with all the other groups. So this one's going to be B and this one C. So if we go A to B and B to C, that's, so A to B to C is clockwise. But remember in Fisher projections, any atom on a horizontal line is up in front, and any atom on the vertical line is back. So this H is up, so even though it's clockwise, we need to assign the opposite, so that's going to be S. If we do the same thing at the bottom one, this is A, and I'll just put a little dot there to distinguish it from the top. This one is D, this one is going to be C, and this one is going to be B. So again, A to B, B to C. So again, A to B to C is once again clockwise. But once again, our hydrogen is on a horizontal, it's up, so that one is S as well. Okay, so S and S for those two chirality centers. And remember, diastereomer, that is not the mirror image, and it's also not the same molecule. So again, if we draw our bars here for our Fisher projection, our CH3s we can leave where they are. But now the two OHs are going to have to be on the same side. So not the mirror image, but not the same. So if we put this OH here and our hydrogens there we are. And again, these are still chirality centers. But again, look at this one. So it's not the same, and it's not the mirror image. So this is the diastereomer. But look at this. It has the internal mirror plane. So the top half and bottom half are the same. So this one is actually a meso compound. And we talked about that before break. Okay, so hopefully that helped you with figuring out the details for the March 23 worksheet, and the materials for Wednesday's class will be posted shortly.